I've recently reviewed and described a couple of IC testers that were produced and sold over places like Amazon and eBay. And I also acquired a more, well, I wouldn't say generic, but it's a non-IC tester. It's for testing other solid state and discrete components that are not ICs. So I guess I should most accurately call it a discrete electronic component tester. But it is sold by all sorts of places and with different case colors and slight differences in description. It's hard to tell if they're all coming from the same factory. But I purchased one from eBay, and this is what the listing looked like. It's described as a transistor tester, TFT diode triode, capacitance meter, LCR, T6, TC-1, NPT, PNP, MOSFET, etc. It all just sort of runs together. And now this is a US distributor, but it's clearly a generic Chinese product with no brand name on it. Sells for about $30, some places a little bit more or less. I went with this one because they appeared to have support in the US, although when I asked questions about it there wasn't a whole lot there. And I'm going to describe how it works. It's a multi-function tester, and it's only labeled TC-1. There's no brand name given, but eBay and Amazon sellers, quite a few of them, sell the same unit. Sometimes there's a slightly different cosmetic color, like they might have a yellow case or something, but I think it's probably about the same unit. Anyway, this particular model seems to be the most popular. One of the Chinese websites, I forget which one, it's kind of like the Chinese eBay or something, I saw it listed on there. This one, and they actually gave a brand name, but I think that's probably just the brand that one particular seller assigns to it. I think these are intended to be brandless. Anyway, it's a relatively small enclosure. You can see it's a decent handheld size. It does not have replaceable batteries. It uses, I believe it's a lithium-ion battery. And it comes with a very short USB cable from a micro USB connector, which plugs in here, to a regular full-size USB connector that would plug into your computer. Or you can just plug in a USB wall wart as well. And there's an LED here. It doesn't describe, there's no manual that came with it, but presumably it changes colors or flashes or something to tell you the difference between charging, charged, and needing to be charged. So that should be fairly straightforward. Unlike the other testers I showed earlier, this one doesn't have a monochrome LCD. Instead it's, I don't know if it's a color LCD or if it's like a organic LED type of thing. Anyway, it's a color display. So I'm going to put it through a few of its paces. One of the keys to operating this unit is to pay attention to the numbers on the ZIF socket. In the lower left-hand corner are the letters K, A, and A. That's for cathode and anode. The two A's are electrically the same. I'm not sure if they're actually tied together. I haven't scoped them out with a continuity checker or an ohm meter. But functionally they're the same point. They may actually be separate pins into some internal microcontroller for all I know. But those are for testing things like LEDs and Zener diodes and such. It doesn't seem to list it as being a diode checker, but it definitely is supposed to be a Zener diode checker. And I think the main thing it does is it tells you what the Zener voltage is, or the forward voltage. Otherwise, all the pins on the ZIF socket are numbered 1, 2, and 3 in different patterns. And that's just for convenience with different pinouts of various devices you can plug in here. So you can use any 2 or any 3 of the pins as long as you don't use number 1 more than once, number 2 more than once, or number 3 more than once. Again, I don't know if those are truly electrically contiguous or if they are different pins into a microcontroller that just regards them as being the same. You'll also notice a small window on the front, looks like a black dot that says IR. In addition to this thing testing components, it also will tell you if your infrared remote control is basically functional. If you use anything other than the Hitachi chipset, supposedly it just lights up an indicator on the screen to tell you that it's receiving a valid signal, you know, decent signal strength and so on. If you have one of those using the Hitachi chipset or a compatible protocol, then in addition to telling you that it's getting a good signal, it will actually show you the digital waveforms on the screen from what's being sent by the remote control, and also interprets what those signals mean. So that can be a useful troubleshooter. So it's a very inexpensive unit. I forget what I paid for this. I thought it was only around $30. And let's see about firing it up. The tester also comes with these 3 short test clip leads. One end is just a pin connector that can go into the ZIF socket. And I don't know, these are probably about 6 inches long, and they have very small hook clips spring-loaded on the end. These are really inexpensive ones. They're not like the nice Pomona Electronics ones, but they're adequate for the task. These are primarily intended for connecting to devices that can't be plugged into the ZIF socket for because of their pinout or their physical size or the thickness of the leads. Maybe you're too thick for the ZIF socket. They're also useful for doing a self-calibration and test. The unit does a self-power-up test every time you turn it on, but if you short all the leads together, then it does a calibration. So here I've got all 3 connectors tied together. I suppose you could just use a couple of short wire leads into the ZIF socket if you don't have these for some reason. Anyway, I'm turning it on by pushing the start button, and it comes up and says it's in self-test mode. And partway through here it's going to prompt me to isolate the probe. PLS means please. Please isolate the probe. So the easiest way to do that is just to pop the ZIF socket and lift the leads out. And then it continues. And I should note that those 3 test leads were in the 1, 2, and 3 positions of the ZIF socket at the upper left-hand corner of that socket. But I could have put them into any of the 1, 2, and 3 holes. So now it's just sitting here and it's still thinking it's testing, but it doesn't recognize what's plugged in because nothing's plugged in. So I'm going to start with some capacitors. It does make a point in the documentation I found online, which was hardly a manual, but at least some advice. It's not apparently got much protection against over voltage or reverse voltage, so the only components this tests which would have a voltage on them when they're not connected to the tester would be capacitors. So it's advised to touch the leads together before plugging them in. So I'm going to just randomly pick, I don't know, I'll put it in. So I've got it in positions 2 and 1 here. 2 there, and 1 there. And the negative side is in position 2. I don't know that it'll tell me that, but power it up, says it's testing. It also shows you the battery voltage initially, and it comes up with a 450.1 microfarad capacitor. I have previously tested this in my benchtop digital LC bridge, and it showed it as being a 431 microfarad capacitor. Oops, let's try that again. Well, right here in the middle of my test, the battery failed on this, or was too low anyway, so I've plugged it into a generic charger that could be used for any number of things, and it's powering the unit now. I've got a red LED on there, which apparently indicates it's charging. Maybe it turns to green when it's charged, I don't know. So here's this electrolytic capacitor again, and it's showing 448 microfarads, and as I mentioned before, my benchtop tester says it's 431 microfarads, so there's a bit of a discrepancy there. And it does power off pretty quickly after, so you have to read it pretty promptly. And it does show V loss is 0.9%, and the ESR is 0.03 ohms, so it tests that as well. And it shows which pins it's connected to. It showed 1 and 3 there, which is correct. So I'm going to go to a smaller electrolytic, which is ostensibly a 1 microfarad part. Got it into pins 1 and 2 of the ZIF socket. And it's showing a 1045 nanofarad, which is correct, and 0.7, let's try that again, it went away too quickly. A V loss of 0.7% and an ESR of 2.9 ohms. Now this same capacitor in my benchtop tested out as a 0.947 microfarad, so again there's a discrepancy in the reading between the two units. I don't have a third device to test these, so I'm not sure which one's more accurate, but I tend to believe the benchtop one's the more accurate one. So it gives you a lot of resolution here, but I'm not sure the accuracy is really all that tremendous. I've got a small disc capacitor here. I don't know its capacitance. I'm going to drop it into terminals 1 and 3. Well, actually I do know its capacitance. My benchtop unit said it was 3.94 nanofarads and 394 picofarads. So yes, that one agrees. And notice in this case it's not trying to give you the ESR values and so on. I don't know if it does that only above certain capacitance values, or maybe it detects that it's an electrolytic, I don't know. But it did identify the pins that it's plugged into, which is 1 and 3. So that seems to be pretty functional. I have an inductor here, a small, not very fancy inductor, which I previously tested at 2.1 millihenries. Now the leads on these are a little bit fat, but they do barely go into the ZIF socket. See what it comes up with. 2.08 millihenries, so really close to the 2.1 at the benchtop unit, and it shows it a series resistance of 141 ohms. And now I have a sort of a miscellaneous Zener diode. I'm not really sure which one I have there. And it's plugged into the cathode and the anode pins, and it identifies a Zener with a 6.22 volt, and it shows the cathode and the anode on there. 6.22 sounds kind of suspicious. I don't know that that's exactly right, but I seem to remember this was supposed to be a 5 point something, just because I didn't usually keep any other Zener voltages in my bin. But the part numbers come off of it, so I can't read it. Anyway, I'm going to pretend like I trust it. Now I just have a standard little metal film resistor here. And here's one place where the variety of pinouts on the ZIF socket come in handy, because obviously the pins are further apart. So I've got it into a 1 here and a 3 over here. And my ohm meter says this is a 3077 ohm resistor, 3107, so this is reading a little bit higher but it does show it on pins 1 and 3. Certainly it's in the ballpark. In theory, this can test LEDs, although I think it just treats them as if they were Zehners. There, I've got it in on the K and the A. Going to turn it on. Identifies it as a Zehner with a Zehner voltage of 26.6 volts, which seems really bogus for an LED. It shouldn't be that high. What if I flip it around the other way? Try it again. Now the LED lights up. It still identifies it as Zener, but now 2.09 volts, which is closer to what I would expect. I would have expected it to be somewhere between 1.5 and 2 volts. So in this case, the cathode and the anode of LEDs is relative to their normal forward operating function, and the Zener voltage is reverse of that, so that's why it read a bogus value when I had it in the other way, but it did work. Now this also will test transistors. So I just grabbed a generic transistor out of the parts bin, and I believe it's a 2222, and I'm going to turn it on. Identifies it as a bipolar junction transistor, NPN, emitter on 1, base on 2, collector on 3, identifies the HFE. It goes away too quickly, so I should stay down a little longer. It shows the HFE, the VBE, and the collector current it's using of 6.3 milliamps. So that identified the part correctly. I don't know if the HFE and so on are really correct, but I imagine they're in the ballpark. I have another transistor here. I have no idea what it is. Just laying around in my miscellaneous transistors bin. This is a PNP bipolar junction transistor. Identifies the pinout, the HFE, the VBE, shows you the IC it's using. And I believe this guy here is some sort of an FET. Just for yucks, I'm going to put it down on those pins, and it comes up with an N-channel JFET, identifies the gate, the drain, and the source, ID, and the voltage on the gate. So definitely useful in that regard. Now a big mystery to me is it came with this in the bag. I have no idea what you're supposed to use that for. It occurred to me that maybe it might sort of line up in some way to act as the testing jumper for shorting all the leads together, but no reasonable way I twisted it would it line up with pins 1, 2, and 3 anywhere. And the pins are pretty fat, so I don't know what they're thinking. Would have been nice if they'd left some sort of explanation or instructions on this. Okay, so I'm going to try out the infrared receiver function now. I'm going to turn it on, and I'm going to aim this Grace Digital at it and see what happens. And you can see in the upper right hand corner here that a red dot appears. This is indicating that it's receiving a satisfactory infrared signal, but in this case it must be using the Hitachi compatible set because it's reading out the infrared decoder information, the waveforms. And let's see, this is the P1 key. It shows a waveform, it shows the data code and the user code, 01FE. And if I push this one, it changes to O2FD. If I push P3, it changes to O3FC. As I push different buttons, it shows the different waveforms and the different codes. It consistently shows the 807F, so that's the user code. I believe that identifies which remote control it is, so they don't get confused, but the data code is changing, so that's a pretty useful thing. Now that's on the Grace Digital one. I wonder what happens if I use this Panasonic DVD remote control. Will I get anything? Oops. Let's try that again. Timed out. So it shows the red dot, but it doesn't give me any information. So that's not compatible. So I've randomly grabbed a few more remotes. I've got one from a Pioneer DVD player, and that recognizes that one. In this case, it's changing the user codes with different buttons. It's also changing the data codes. So it seems that the Pioneer is using something it recognizes. And if I try the Samsung TV, it's recognizing that. Well, at least it's partially recognizing it. It's not changing the codes. Now it's not. So maybe it's still showing something left over from the old one. Going back to the Pioneer one. It's reading that. I switch over to the Samsung. Oh, I guess it's just still holding the waveforms from the other remote control, and here it's just showing me the red dots. And just for yucks, I've got an old Panasonic VCR remote control. I wonder what happens with that. Nope, it's giving me the red dot, but that's it. So it definitely works with more than one brand of remote control. That could be pretty handy. So I think for the price, this is a very useful device. If for nothing else, it seems to be pretty reliable in identifying pinouts of devices and identifying the general type of the device. I am skeptical about how accurate its readings are, but they do seem to at least be in the ballpark. You know, the thing doesn't come with a certificate of calibration or anything, so, you know, it is what it is, as they say. Still, I think a pretty decent device.